Hi guys, how are we? So we're on to lesson number 2 of week number 8. I'll chat to you all on Friday morning, and we'll do our live lesson, which will be our third and final lesson of the week, and hopefully finish off this topic, and we can move on to the little higher level bit then on Monday, which will probably, be honest with you, because it's more tricky, we'll have to be live as well. So we might have a couple of live ones next week, as opposed to just our one on the Friday. Okay, anyway, we'll motor on and finish this off, and we'll do, and on the live on Friday be more of a question and answers job and work it through the revision exercise, so it'll be as short or as long as you need it on Friday, depending on how you're doing. But I don't think, looking at the homework, that many of you have too many problems with what you're doing so far, which is great. So I'm just going to get rid of this big homework sign in the center, so that we can put in the questions and answers and so on. So we start with question number 1. Why not? 1A and B is just using the formula. It's just practice using the formula. So the formula we're going to be using is pi r squared h, I think. We're looking for the volume of cylinders, pi r squared h. And in this case, they want us to, pi is going to be 3.14. So they're not going to be leaving pi in the answer, or you're not going to be using 22/7, you're going to be using pi r squared h. Okay, so if we look at that first cylinder on the left hand side there, where our formula, so our volume is going to be 3.14 instead of pi. The radius is 6 squared by the height, which is 5, and you can chuck that straight into a calculator. I could work out 6 squared first, then multiply by 3.14, and then multiply it by 5. My answer is always going to be in centimeters cubed because I'm dealing with volume. It'd be squared if we were dealing with area. And when you put that into a calculator, you get 565.2 centimeters cubed. For part B, it's the same formula. So we're going to have volume is equal to, so we're doing this one here. I think that's a 4. I can't see it because of that. It's going to be pi, so 3.14 r squared, which is 4 squared by the height, which is 5. Into your calculator, your answer is going to be in centimeters cubed. I always put the centimeters cubed down before I put the answer down in case I forget. And when I go over, when I multiply that into my calculator, then it gives me 401.93 centimeters cubed. No, 0.92 centimeters cubed. It doesn't say leave to 1 decimal place or 2 decimal place or anything like that. Moving on then. So that was just using the formula. Most of these questions are just using the formula, to be honest with you. To question 5. So it was 1, 5, 7, and 9, wasn't it? So question number 5 here is there on the center of your screen is 5. Find the radius of each of the following cylinders. Okay, so they're giving us the volume, and they're giving us the height. So we're going to do, we've cylinder A and cylinder B, so we'll do it as part A and part B. So this time we're going to have our volume, so same formula, is pi r squared h. In this case, they give us the volume is 1280 pi. So 1280 pi, I sub in for volume, is equal to pi r squared h. So it's going to be pi, radius is what? Where's the radius of this cylinder A? They're not giving us the radius, are they? Volume. No, they're not. They're not giving us the radius. Okay. Oh, why would they give us the radius when they're asking us to find the radius? What am I talking about? Pi r squared by our height of a cylinder is 20. I'm thinking, why are they giving us that? Pi r squared by 20. Now, you could divide both sides by pi and get rid of pi straight away. So, or you could sub in 3.14, which would cancel out anyway. So what you end up with is 1280 is equal to 20 r squared. Or r squared is equal to 1280 over 1280 over 20, or is going to be equal to the root of 1280 over 20, which means I'm going to sub that into your calculator, which I'm going to do now, is going to be equal to, it's going to be equal to 8. Okay, 8 centimeters. So 8 is equal to or is equal to 8 centimeters. Okay, for cylinder B then. So B, we have, what are they giving us here for cylinder B? I'm just checking the answer there, is 8. For cylinder B, I'll try and squeeze it in here beside A if I can. So for cylinder B, we have the volume is 3633 and a 1/7 meter cubed. Okay, so we have 3633 and a 1/7, and it's not a third, and a 1/7. So there's our volume is done for us for B. And they've given us the height, and they've wanted to sub in for pi is 22 over 7. So there's our volume is equal to pi r squared h. So pi 22 over 7, because they want us to sub in. So pi multiplied by the radius squared, which we don't know. Am I right in saying that? We don't know. By the height, which is 4. Okay. So we work that out. So what that's going to work out is all this side here works out at 88 over 7 or squared. So basically all this part here, when you multiply 4 by 22 over 7, it gives you 88 over 7 or squared, is equal to 3633 and a 1/7. I've done nothing on the left hand side. So what we're going to do is then, if we have something r squared is equal to this, we want r squared by itself. Or you could just, but you're leaving with a massive square root, a horrible looking sum. So I'm just going to leave the r squared by itself for a second. And what I'm going to do is I'm going to divide this into this, which is going to give me 289. So it's just a big arithmetic sum. 88 over 7, or you can put that into a decimal if it makes it a bit easier. And you're going to divide that into 3633 and a 1/7. Okay, into your calculator. Then what we go to get from r squared to r is equal to the root of 289. Or r is going to be equal to 289 is 17 meters. Like so. You can see that, 17 meters. Okay, let's check that. Does it work? No. Yes, there it is. Extra beside it. It's brilliant. Okay, r is equal to 17 meters. Okay, move on and let's have a look at number 7. So number 7 is here. So we're dealing with the wooden block. I had to leave it kind of small so I can write. So number 7, a wooden rectangular block is shown. Okay, so we have a length, a width, and a height. So we can get an area, we can get a volume. Find the volume of the regular block. Okay, so the volume of the regular block is going to be 70 by 50 by 30. 70 by 50 by 30. So when you multiply that out, it's going to be big. It's going to be 105,000. And we're looking for the volume, so it's going to be centimeters cubed. 105,000 centimeters cubed. Okay, so we found the regular block. Now, taking pi as 3.14, find the volume of a cylinder of height 30 and radius 15. So height 30 and radius 15. I'm going to find a spot to do this. Okay, you have it in the video, so I'm going to get rid of question 5 here, right? 5a. So same formula, using the same formula again. What we're going to do is find the volume of a cylinder of height 30 and radius 15. Okay, so our volume is pi r squared h, so our volume is going to be 3.14 pi, or radius squared is going to be 15 squared multiplied by the height, which is 30. Okay, straight into your calculator. This is going to be in centimeters cubed to find the volume of our cylinder. And the answer works out as 21,195 centimeters cubed. Okay, so we've done part C. So we've done part B. Part C of 7 is find the total volume of the two cylinders. Oh, so two such cylinders are to be cut out of the wooden rectangular block. So out of your wooden rectangular block, and we worked out the volume of that already as 105,000 centimeters cubed. And they're going to cut two cylinders out of this rectangular block. What would the volume be of those two cylinders? Okay, well, if here's the volume of one, is going to be the answer we worked out a second ago, 21,195. So you're just going to do 21,195 by 2, which is going to be, just do that, 42,390 centimeters cubed. Okay. And the last part says, find the remaining volume of the wooden block. So after you've chopped your two cylinders out of it, what's left? And you know at the start that you had 105,000 was the total volume. Take away what you've done, take away the two cylinders, 42,390. And that's going to be, again, we're sticking in centimeters cubed. The answer is going to be 62,610 centimeters cubed. Okay, any question on that, of course, you can ask me separately, and I can do them out for you and put an audio note in and let you know that's been done. Okay, our last question, we have a bit more space this time. Okay, we'll draw a line under this one. So question number 9. Again, we're still assuming it's going to be looking at the volume and stuff. So a cylindrical saucepan and cup are shown. Yeah, fair enough. There's a pot and a cup. Fair enough. The diameter of the saucepan is 30 and the diameter of the cup is 9. Find the volume of the cup and give your answer now in terms of pi, which means we're not subbing in for pi. So when it says in terms of pi, we leave pi where it is. Okay, so we're looking for volume, and that cup is a cylinder as well, so it's a cylinder shape. So we're going to use our same formula, pi r squared h. That's going to be our volume. So what we're going to do, we're going to sub in what we know. Be very careful. They've given us a diameter as opposed to a radius. So our volume is going to be pi radius squared. Because the diameter is 9, the radius is going to be 4.5, half the diameter squared, by the whole height, which is 10. I'm leaving the pi there because it told me in terms of pi. Throw it into my calculator and I get 202.5 pi, because we didn't sub in for that, centimeters cubed, because it's volume. Okay, part B. The saucepan holds 20 times the volume of the cup. So basically you can fit 20 of these in that pot. Okay, so what volume of soup does the saucepan hold when full? So what volume of soup does the saucepan hold when full? And they still want us to give our answer in terms of pi. So let me just say this is part A, and down here then we're looking at part B. Okay, so what we have, we know the volume of the cup is 202.5 pi, and we know that it takes 20 of them to fill up the saucepan, so we multiply that by 20, leaving the pi alone, centimeters cubed down, because we're still dealing with volume. When you multiply 202.5 by 20, you get 4,050 pi. Don't forget the pi, because we're still in terms of pi. Okay, that's part B done. Might be able to squeeze C in here as well. Let's see, what is the height of the saucepan. Okay, we stick with the same formula to find the height of the saucepan. So we have pi r squared h is equal to 4050 pi centimeters cubed, because that is what we worked out to be the volume of the saucepan. Okay, so we're saying, well, the volume is what we've worked out, but we're now looking for what they ask us for, what is the height. So height we don't know. You can see on the diagram there, they're not giving us the height. So that's what we're going to work out now. Okay, so basically, and to be honest with you, when I'm working with these formulas, I like to get me h on its own. I like to get what I'm looking for on its own at the start of this, but it's up to yourself. You can sub in the left, sub in the right, and then leave it at that. Because we have pi on both sides, we can divide both sides by pi. You're going to do it anyway. We can immediately say, because it doesn't say what to sub in for, it doesn't say in terms of pi, we can immediately get rid of pi. We sub in what we do know. So we do know that the radius of the pot, careful again, they're giving us a number here that they're tempting us to use, but they're giving us a diameter. So we're going to have 15 squared, after getting rid of the pi's on both sides, dividing both sides by pi, 15 squared is equal to 4050. So 15 squared is going to be equal to 4050. Not to forget our h. So 15 squared h is going to be equal to 4050. Okay, so what you can do then is, if you have 2h equals 4, leave the h on its own, and you're going to have 4050 divided by 15 squared. Or you can square the 15 on the left first before you bring it over to divide it in. And when you work that out, you get, just doing it quickly on the calculator, h is equal to, my calculator is showing me 15. 4050 divided by 15 squared gives you 15. What did they work it as? 4050 divided by 15, sorry, 15 by 15, that works out, so 4050 over 225, so 4050 divided by 225, not 15, it gives you 18. Okay, so the height is going to be, and it's in centimeters, so the height is going to be 18 centimeters. Okay, I was doing 13 squared as well as 15 squared. Okay, so let's go on and look at the last part of this question, then D. So part D, for safety reasons, the level of the soup in the saucepan is never more than 16 centimeters high. Right, we have to work it out now to be 18 centimeters is the height. How many full cups of soup can you get from the saucepan? So how many full cups of soup can you get from the saucepan? So, well, if we work out the volume of the saucepan, so the volume, let me see where I'm going to fit D in. I'll fit D in here, right? I'll fit D in this spot here. So, D, okay. So the volume of the saucepan, remember we're still going pi r squared h, so it's going to be pi 15 squared by 16 pi r squared h, and that's going to be equal to 3,600 pi. Okay. Again, we can get rid of the pi's straight away. And when you work that out, we're still looking for, what did the question ask us to look for again? Sorry. How many full cups of soup do you get from the saucepan, right? So we're doing, the volume is pi r squared by h. The volume is pi r squared h. Okay, so what we end up with is 3,600 all over 202.5, which is equal to, so what I've done is, and when you multiply 15 squared by 16, it gives us 202.5. When you divide that in, it gives you a funny number. It gives you 17 recurring, so it gives you 17.1717. But the question asked us, how many full cups of soup do you get? Okay, so then it is 17. And over here, yeah, it's saying 17 full cups of soup. Okay, kind of complicated going back and forward and left and right and up and down and question, blah, blah, blah. Anyway, right, so any question on that, guys, you can ask me. And again, on Friday, we'll be pretty much finished all the stuff from this topic. So there'll be plenty of time for you to ask any questions that you have, or we can go over any ones that caused a bother during the week, and not just in volume, but in area, and of all the triangle and the rectangle and the cube and the cuboid and all sorts of stuff. So this is our last thing to have a look at in this topic. And here it is. So, scale diagrams. So, and you did this in geography a fair bit. Obviously, if you get a map of Ireland, it's not going to be the same size as Ireland. It's all scaled down. So if you have a map of Ireland and it says, right, Dublin's here and Cork is here, and it's only 5.1 centimetres between Dublin and Cork on the map. Obviously, Cork is a bit further away to Dublin than it is. And what they're saying in this question is that the actual distance between Dublin and Cork is 255 kilometres. So to go from Dublin to Cork is 255 kilometres. On the map, how many kilometres does each centimetre represent? Well, if we know that if 5.1 centimetres tells us that it's 255 kilometres, we can work out what 1 centimetre is. 1 centimetre is 255 divided by 5.1. When you divide that in, it's 50 kilometres. So 1 centimetre is equal to 50 kilometres on that map. So another one, if Donegal is 8 centimetres from Cork on the map, how far is this in real life? Okay, well we know then, we're after working out already that 1 centimetre is 50 kilometres. So 1 centimetre is 50 kilometres. So if we're dealing then with 8 kilometres, multiply that by 50, it'll give us 400 kilometres when you work it out. Okay, so you can work out the distance if you know how much 1 centimetre is. And we did a lot of this when we did speed, distance and time as well. Okay, so your homework for lesson 3 and what we'll be going through live on Friday is, I'll just put it up here in the corner. So it's due Friday. Exercise 27.6, and I've highlighted them in there for you. It's question 2, 4, 6 and 8. Question 2, 4, 6 and 8. But before we go, there's a question here, question 7, we can have a quick look at, just for the sake of doing one of this type. So question 7. And in question 7 there, it says, John walks... There's your homework there, and I've written the homework. Sorry, I forgot to scroll down. I'm doing this on the iPad. So there's your homework there, 2, 4, 6 and 8, and I've highlighted them for you. So 2, 4, 6 and 8, all to do with scaling, and a bit of scaling in different shapes and so on, so you can have a go at that. But what I'm going to do first, I'm just going to do question 7 for you before we finish, just to say I did one of them. So it starts down here, and and goes up here. So John walks in a straight line for 150 metres. There we go. He starts over here, does a 150 metre walk in a straight line. So basically his line is from here all the way along as far as here. Joan even. She then turns 90 degrees and walks another 80 metres. So the red line is his walk and walks 80 metres. Fair enough. So 150 and 80. Don't know what the sum is yet, but I'm thinking, well, his total walk then is going to be 230 metres total walk. Don't know what the question is, but we'll have a look now in a second. Draw a scaled diagram of her journey. So a scaled diagram of her journey using a scale of 1 is to 1,000. So a scale diagram of her journey which 1 is to 1,000. Right, so if we do the maths on that then, well, if we're looking at 1 is to 1,000, that's going to mean 1 metre is 1,000 metres, meaning 100 centimetres is going to be 1,000 metres. That makes sense? So if we're going 1 is to 1,000, that means 1 meter is going to be 1,000 meters, and 1 meter is going to be a kilometer on this scale diagram. 100 centimeters, which because it's 100 centimeters in the meter, is going to be 1,000 meters. If I bring that down, then it means 1 centimeter is going to be 10 meters. So 1 centimeter is going to be 10 meters. So what I've done there, basically, I've knocked off 2 zeros off that on both sides. So if we then look at the two things, you have 150 meters to worry about, and we've 80 meters to worry about. So if we go, okay, well, here's our 10 meters, 150 divided by 10, which is going to give us 15 centimeters. So that's how long the first stage of the journey is going to be. It's going to be 15 centimeters. And the other one then is 80. So 80 divided by 10, which is going to be equal to 8 centimeters. So when I draw my line then for part A, I am going to do 15 centimeters this way and 8 centimeters that way. So this is going to be 15 centimeters, this is going to be 8 centimeters, this is going to be end, this is going to be start. So I've scaled down from 150 meters and 80 meters into a diagram that represents that distance in a smaller term. So 150 to 8, 150 and 80 goes to 15 and 8, which stands to reason, doesn't it? Okay, the second part we actually can't do. Second part is use this drawing, calculate the distance between her start and we can between her start and an end point. So, well, if 17 centimeters on the diagram, so if we have 17 centimeters on the diagram, that is going to be 170 centimeters. So basically 15 centimeters in the diagram is going to be 150 meters, and 8 centimeters is going to be 80 meters. So the question asks, calculate the distance between our start and end points. Well, it's going to be 150 and 80, which is going to be 230 meters. So that's the real difference. The scale difference is going to be 15 plus 8, which is going to be 23 centimeters. Like so. Okay. Right. So I'll leave some of those questions for you to have a go at, and we'll correct them live on Friday. It's 2, 4, 6, and 8. Question 2 is just practicing your scales. So going from, if 1 is to 1,250, if the actual length is 500 meters, what's the scale length going to be? And so on. So you're just filling in different scales. Divide one into the other, basically. Okay. Question 4 is draw a graph paper. So a bit of drawing. It'd be difficult for me to do live, but I'll work it out before then. Question 8 is things like architectural drawing. So people who do TG will be a dab hand at this. It's just scaling up and scaling down. This is part of the tech graphics course as well. And back up to question 4 then is another one to do with maps. So you can scale up and scale down buildings, countries, globe of the world, right down as a scale model of a railway, things like that. So this is just scaling up and scaling down and getting used to going from big size to small size and small size to big size and so on. Your homework is there. 4 questions, and then you won't have homework on Friday after we finish off correcting these, and we'll try a few revision exercise questions, kind of put the whole thing together. So going from area of squares and rectangles to volume and then to practical examples. And on to higher level next week. Okay, talk to you Friday. Mind yourselves. Bye bye.